Hi friends, today we are going to see a new topic in semiconductor which is Hall effect. The Hall effect is first we'll see the statement of the Hall effect in which if a metal or a semiconductor strip carrying a current I is placed in transfer magnetic field B and electric field E is induced in the direction perpendicular to both B and I. I am repeating again. If a metal or a semiconductor strip carrying a current I is placed in transfer magnetic field B and electric field E is induced in the direction perpendicular to both B and I, that is magnetic field and current. This phenomenon is known as Hall effect. Now, to obtain the equation in Hall effect, that is the equation of Hall voltage and Hall coefficient, will consider the let electric current is flowing through a slab of a conductor or a semiconductor along its length, that is current is flowing along its length L. So just see the diagram. See this diagram. We can consider these as a conductor, that is metal or semiconductor, because this Hall effect is applicable for both, that is conductor or semiconductor. Now see, this slab, this W, this width, then this is D, then this is L. Along these length, current is passing. Magnetic field is applied to the slab perpendicular to direction of current and along its thickness. So along the thickness B is applied, this magnetic field is applied. See, along this D. Due to the force of magnetic field, that is Lorentz force, the charge carriers are deflected towards positive edge of the slab. We know the Lorentz force. When there is magnetic field and uh, current flowing through the conductor, then the charge are deflected due to that magnetic field and some force acting on that charge due to magnetic field is given by a Lorentz force. That Lorentz force is, we already know, F. That equation we'll see later. This Lorentz force generates electric field and develop potential difference across the edge of slab. Whatever the current and magnetic field, they generate electric field. Electric field is generated and develop potential difference across the edge of slab, that is along the width of slab. So according to definition, when current in one direction, magnetic field is the other direction which is perpendicular direction of current, then electric field is generate which is perpendicular to both. So current is along the length. See here, current is along the length, magnetic field is along the thickness. So electric field will generate along the is width. See this width. Okay. This electric field is perpendicular direction of flow of current and magnetic field. Now consider a slab of a conductor or semiconductor as shown in figure. Again same figure. Now we'll give some notations. Let W is the width of slab. This one W is width, then D is the thickness, this one, then I is current flowing the slab, this current actually this along this direction, this by mistake shown here, it is along this direction, and the charge concentration, that is number of charge carrier per unit volume, is the charge on carriers, then V sub d is the drift velocity of charge carrier. We know the drift velocity. Drift velocity is the directional velocity under the influence of electric field. A is cross section area of slab. So cross section area we can write as A is equal to V cross D or V into D. This, see, this cross section area we are considering. So width into thickness. Now, due to current I, electrons move along the length of solid. When magnetic field of strain B is applied perpendicular to thickness of slab, charge carriers experience force, that is Lorentz force. That equation we already know. So we write the equation of Lorentz force, which is due to the magnetic field. So Lorentz force F is equal to magnetic field into charge into drift velocity. So F is equal to B E into V suffix D. Sometimes instead of E we have used Q, but here we know either is conductor or semiconductor. So electrons or holes both having same charge, which is E is 1.6 into 10 raised to minus 19. So F is equal to B into E into V suffix D. Let's the equation number 1. Now electric field is developed across the edge, which is E suffix H. This electric field E is electric field and this suffix H is for Hall effect. So E suffix H we can say electric field developed due to Hall effect, which exert an attraction force on charge carriers. It exerts a force on charge carriers in opposite direction. The force due to electric field on charge carriers is given by the equation F is equal to small e into capital E. See again, this is a force acting on charge due to Lorentz force, and this force is due to electric field. We know this Lorentz force, the charge move upward direction, and due to this the force charge move downward direction, and both force acting simultaneously. That time charge is moving in straight line. So these both are the forces which acting on carrier, and due to that it get equilibrium position. We can compare these both functions, both forces. So we can write B into E into V suffix D, which is given by Lorentz force, and these another force E into capital E suffix H, okay, which is given by electric field. So capital E suffix H can write as B into V suffix D by cancelling this small e from both sides. Let's see equation number 3. If V suffix H is a potential difference generated along the width of slab due to the electric field EH, then, see again I am repeating, V suffix H is potential difference generated along the width. We know when electric field is developed, that time voltage will be generated, and that voltage is always uh, along the direction. So we can write E is equal to V by W. That is, we know the electric field is potential per unit dimension. So along which direction that electric field generate. So that time we are writing voltage upon that direction. So here electric field is generated along the width. So we are writing E suffix H is equal to V suffix H upon W. By putting the value of EH in above equation number 3, so we'll get V suffix H upon W is equal to B into V suffix D. So take this W this side, so we get V suffix H is equal to B into V suffix D into W. Let this equation number 4. But the current passing through conductor is, we know the current passing through conductor is I is equal to NE into A V suffix D, that we have already seen. N is charge carriers, A is the charge, A is the cross section area, and V suffix D is the drift velocity. So from this, just take this NEA this side, so we can write drift velocity is V suffix D is equal to I upon NE I upon NEA. Let's do equation number 5. So from equation 5 we can write equation 4 as VH is equal to B into I upon NEA into W. So just take this NE separate. So we write 1 upon NE into this remaining part as equation number 6. This 1 upon NE is a new quantity, new constant we are considering. This is R suffix H, and this is known as Hall coefficient. So we can write this equation number 6 as V suffix H is equal to R suffix H into BIW upon A. This equation number 7 gives the Hall voltage. I am repeating, V suffix H is equal to R suffix H into BIW upon A, which is the Hall voltage. As Hall voltage is VH is equal to RH BIW upon A, and cross section area is A is equal to V into D. The front side we are considering width into thickness. Just substitute here value of A, will get V W into D. This W get cancelled, so remains VH is equal to this RH BI upon D. From this we can write RH. Just take these all terms to other side. So we'll get the value of RH as R suffix H is equal to V suffix H into D upon BI. This RH is, this equation is known as Hall coefficient. So in this part we have seen the Hall voltage and Hall coefficient. So we know the what is Hall effect. Hall effect is, in other word we can say, if current carrying conductor is kept in transfer magnetic field, that time we are getting electric field, and the equation of Hall voltage is V suffix H is equal to R suffix H into BIW upon A, where RH, that is Hall coefficient, is V suffix H into D upon BI. Here directions are important because we are getting potential or electric field, electric field is along width. So in this equation W is here. So these are different depending on the direction. Okay, thank you.